How's it going, everyone? A.K.A. Gonzalez again, looking at the React Performance, a course taught by Steve Kinney, head front-end engineer at Temporal, this open source durable durable execution platform that you can think of this like a business use case for Kubernetes to cover a particular business use case. And because the idea of today's video is to, before looking at the React performance, we need to know is that how React works behind the scenes as a way to be able to describe all of this inner mechanism, whether it is for college or for non-tech savvy, for example, business people, shareholders, your users, as a way to really understand how these things work, and when it comes to actually now write performance React components and therefore React applications, then using is frameworks like Next or Remix. In my particular case with Next, now we will able is to actually know how to identify all of those performance issues and come out and develop a tool set that allows to not only to identify but also to apply a solution or come up with some best practice when you find them. And that's, I think, the end goal of looking at the React performance. So anytime when someone say, hey, who's come to solve this? Eulier. Shit. They know that I'm going to do that. So that's also part of the reason of being very, very good at doing the thing that you do, as a way to have this now recognize Jesus, as a way to get this recognition, not only in your job but also outside of that, in your professional life. So because of that, I'm going to make a quick recap over what we have learned so far, especially how this course is structured, by looking at the introduction, React rendering, redusting rendering, context and suspense. But what we really care about is to describe these two features, and then we now we're going to make a quick overview of the learn sections as a way to make sense of how do we get here, especially when we need to synchronize with external systems using Effect. So this introduction is, well, as a way to recognize and to understand what is the value proposition of React performance, specifically performance per se. It is faster to not doing things than doing it, and the other is it is fast. There's some corollaries to that. So it is faster to do things later than doing it today or right now. So this is something that you can apply also to your life, and that kind of thing. So also in this introduction, we look at how important it is to understand how React works, as I mentioned before, so you can now identify all of this React performance issue, develop a tool set that anytime you know that, you look at them, you come up with some best practice. So this is pretty much like untying a big knot, all right, where you're going to apply the technique that you already know over and over and over until that's gone. So before that, and because of that, I mean, that's where we need to look at the React rendering. That's where we need to understand how React is working behind the scenes, which means that walk through this learn section and describe all of these concepts and understand all of them. So what we're going to focus our attention is on synchronizing with effects, and you might not need an effect. But before that, well, let me actually take a quick tour here over what is React, Okay, and over all of these sections, as a way to now understand how do we get here, especially with synchronizing effect, or when it comes to synchronize with external system with React. But what is React? So React is this JavaScript framework that allows to describe UI. And the way how can we describe our UI is using JavaScript functions. We export them. So we look at how can we import React components, export them, how can we now make use of this syntax called JSX that allows us to combine its JavaScript nature or the JavaScript word with the HTML, okay? And how can we connect the JavaScript with the HTML tag, that's what they call JSX, with the curly braces. So with that, we also look at how can we now is pass props to these React components as input of a function, as well as how can we now create our components, or how can we render conditional components, render a list of elements here, and how important is to put a key as a way to let React to keep track of all of these elements that you want to render, this collection of elements. Why this is important? Because React will know how to make some performance optimizations, how to keep track of what elements that. So you can think of this like when you have a folder with a lot of documents. So, all right, so now when you pick one or someone pick one or remove one or just shuffle that, you know what's going on there. So when you're writing your React components, it's also important is to define them in a pure way. And what pure means, it's just a mathematical concept that given the same input, you will always get the same output. This mathematical function, okay? So what does it mean? That is that you're going to write your rendering logic, aka in rendering logic, we're going to describe that later. What does it mean? You're going to create your React components in a way that always return is the same. So given this particular input, you always get the same output. Why React cares so much about this? Because now you can run this function or your components in any JavaScript environment. So for example, on the server, you can now pass some data to these components and serve to millions of users. So things are starting to make sense here, and especially when you're starting to use now React components in frameworks, you're starting to see how valuable it is, and also how you can now catch some of this component as a way to say, instead of actually having to re-render this component or recalculate these components, I want you to now have a catch version of that, because these components won't change that much. This UI will be fixed, all right? Or it's rarely that it changes. So that's why we can use, for example, some memoization techniques. For example, like use memo or use callback, okay? As a way to catch this computation or this function reference. Again, we do that for catching, and the other is that when you are now passing data down and you want to stop the execution, it is safely to do that using this approach, or by writing all of your React components in a pure way. So when we look at the importance to write our components in a pure way, aka the rendering logic, and as a way to understand now how React sees our components and how we can actually visualize how React sees our components, is by using the tree data structure, which is a computer science concept as a way to organize our data. Why this is important? Well, because at the end of the day, if you're working with data, You want to find a way to organize that and to operate that. So this data structure is pretty much like you can think of any place that you can store data or retrieve that. So for example, a cabin, your fridge, or your backpack. And each one of them offers certain capabilities. So you can store things there. For example, in your fridge you can store is fish or ice cream. In your backpack is some tablet, laptop, mouse, keyboards. In your cabin, perhaps some underwear, and some drugs as well. Don't, don't. I mean, you can, but come on. Find more useful things to store that. For for a perspective that is helpful for you. Yes, drugs can help you, uh, but if you hit the gym, and here I'm making is an ads to go to the gym, that'll be better. That is a drug, of course, that will allow you to feel better with yourself, and then now exploring this kind of concept. It can be quite confusing at the beginning, and then you realize it's not confusing. It just makes sense. It's just the natural step. It's the logical step to actually do this kind of thing. It's commitment. Anyway, back to our studios here, and which means that um, these data structures, okay, or this is place where we can store data and retrieve that and operate with that. Uh, we have now several of them. So we have now arrays, we have hash or dictionaries, we also have linked lists, we also have double linked lists, stacks, queues, pretty much representation of the real world, tree as well, graph, we also have traits. So in this case, the software engineer at Meta decided to go with this data structure, which is the tree. So the benefit of using this is because now when in your render tree, so you can see how the data go with, how the data go around it, how the data go, how the data flow through that, and how all of these components are organized as a way to identify is potential bottlenecks, performing issues. And then we got is now the tree dependencies, which is some of this reusable logic that you want to add to this component as a way to provide is the necessary interactivity or design or layout that you want to show with. So with that, and when we want to actually to describe is the interactivity, which is the next step in your React components, it is, well, how you can do that. So by attaching is the event handler with a function, or attaching a function with an event handler in our JSX using the curly braces, now we can is response to user inputs. But most of the time you also want is to show some data, and based on that data you want to respond to that or update that. That's where we have now a states, a components memory model. So this state, which is behind the scene, is using closure, which is a nice little bonus feature from React that allows you to is describe. You can think of this that is preserving it's a way of how you can now store persistent data. But the reality is that closure, to be technically specific, so closure hold is a reference of the outer lexical scope data, so you can have access to that even though that function was run long time ago. So this particular pattern of closure enables some of these common patterns that allow to, for example, create models or memorize or run functions once. And that's quite interesting. Totally. It also enables its patterns like promises, uh, part of the async nature, um, as well as iterators. Okay, as a way to hold this information, to keep track of the information as we now define in some iterative algorithm and what to do with them. It's very compelling and very interesting concept. Anyway, back here to how can we define is our states by using the use state, and when you set the state, now React pass through a rendering mechanism as a way to now show you the new state of your UI. So when you set an state, okay, which is something that you do inside of your event handlers, where now React in that moment it allows you to, well, set the state. It will trigger as this rendering mechanism, which is made of 3 phases. You got the trigger, you got the commit, trigger, render, and the commit. So during the trigger, it say, hey, when this happened, okay, it happened at the initial root, or it happened as caused by a re-render, meaning by a component, that a component or any of its ancestors that update that state. So with that, now the next phase is the rendering, aka calling your function. Is this what happened at the initial render element, okay? Or is it happening at the root element in the render tree? So React, what it's going to do is to create those elements using the React.createElements function. And then we're going to store that information, okay, to be later on apply that. So during the initial render, React will create the DOM nodes for that. And during a re-rendering, if this is what happened at the re-rendering, it's like, okay, now React will calculate all of their property and change for that. It won't do anything with that information for now because it will be used by the next stage of the commit phase. And then the output for the components, which is a GSX element, it will say, hey, if you have more React component, let me actually call that, and React will do that in a recursive way, meaning that it goes through that until there is no more component, until it finds this base case. So that's quite interesting and compelling, because once React now call all of these components, okay, it create now all of this information for each one of those components, aka the virtual DOM, which is not a technique. It's not a technology. It's a technique that some frameworks actually use as a way to represent the ideal DOM element in sync with the real DOM. So once you create that, you might wonder that you can ask, for example, claw here as a way to check that. In React, the VDOM is created after the rendering phase. That's not quite correct. Let me explain how the virtual DOM works in React. Initial render, React creates a VDOM representation of the UI, and then it uses this VDOM to create the actual DOM, exactly. And updates, when the state approach changes, React creates new VDOM tree. It compares the new VDOM with previous one different, and based on the difference, it updates only the necessary parts of the real DOM. So the VDOM is actually created before the rendering phase, not after. It's a key part of the React rendering process and help to optimize performance. So it means that if this is an initial render, React create a VDOM representation and then use the VDOM to create the actual DOM. So it means that okay, so based on the React and commit section from the learn topic in the React docs, okay, when the VDOM is created, the VDOM is not creating on every re-render, but rather when they are changed that necessary the update. React reconciliation process use the VDOM to effectively update the UI and minimize by direct manipulation of the real DOM. So, but initially it created that. It's created during the virtual DOM is created during the rendering phase of React rendering process. So, but again, this virtual DOM, its visual representation, is created on the initial render. Okay, so it now has this UI this ideal representation of the UI that keeps sync with the DOM. All right. So with that information on the rendering, now it is time for actually commit those changes. So if this what happened so if this trigger happens at the root element as an initial render, now React will going to append all of these elements to the DOM and show the UI on the screen. However, if this was caused by a re-render, what it's going to do is, because he already have a VDOM, meaning that he already previously computed that. So what it's going to do is to compare that with this new VDOM that is created, and then through the reconciliation process or the phase reconciliation process, using now the Fiber, which is the reconciliation engine, as a way to apply only the necessary change to the DOM. And now this reconciliation engine allows us to do things like prioritize rendering, as well as rendering prioritizations, the ability to pause, abort, and resume rendering. And I think there is another one. And I think this is another one. Yeah, and I think this is another one. And concurrent rendering features. Oh, okay. So all of these are focused. This engine, what allows is to do this kind of thing, and that makes a lot of sense. That makes a lot of sense. So this reconciliation engine called Fiber, which was deployed in React version 16, is now what allowed this. They lay out the foundation to what is now we can use right now. So for example, rendering prioritization or concurrent rendering. That's interesting. Or the ability to abort, or the ability to pause, abort, or resume a rendering. So once we understand this, okay, this piece of this concept here is now we lay out the foundations of what's coming next, which is the final piece, which is when the browser detects those DOM updates, it now it now repaint the UI. So this is important to understand all of these different phases as a way to make sense of how can we now then interact with external system. And I think this is beautiful. In any case, something that we're gonna do that later. But understanding is the fundamental here of this mechanism. Okay, now we'll open up a new opportunities to see what's going on behind the scenes. So for example, how can we think now our state as a snapshot? It means that during rendering phase, the state act as a snapshot. It means that inside of your React or inside of your event handlers, you can think that React fix the state for you during that. And the other is that states are not synchronous. So a state's value updates in the next rendering. All right. So it means that we also have the ability to actually queue a series of state updates as a way to work with the previous states with that. That's quite interesting as a way to work with the previous state with that. So for example here, what batching is and how React used to process multiple state updates. If you want to process multiple state updates and how to apply several updates to the same state variable in a row, so this is one of the things, state updates, multiple state updates. Multiple state updates. So for example here, what it's actually applying is only that. If you want to now is apply several updates to the same state variable in a row, you do is by passing is a function like this. And this is actually doesn't need to match is that, because what you're doing this is to say, hey, I just want is to is the state of this state updater. I want you to now is work with the previous state and apply that. Work with the previous state and apply that. So you might wonder, when do you want to do this? However, as you might recall the previous section, each render state values are fixed. So the value of the number inside of the fixed render event handler is always fixed. So that's one of the reasons why that actually doesn't work previously, because during the event handler, React states act as a snapshot of that, which means that this state will be the same for that. And if you want to work with previous state, you just only pass a functions. So when this is useful, for example, when you want to do some, when you want to work with the previous state with that, all right. For example, by working with async task for that. But that's quite interesting. Again, this now gives you the ability, when you queuing a series of state update, this now gives you is the ability to get all of these state updates, okay? And not only you can work with one particular state with that, but also with the previous states. Something interesting, because now this will unlock powers like async operations. So for example, working with the previous state as a way to update the current state with this new data that you're passing. Useful in timers, for example. So things started to make quite sense here as a way to now move on to the next topic, which is updating objects in states and updating array in a state. So the thing here is that Yeah, yeah, yeah. So the thing here, okay, the thing here is that we are now able to look at that. How can we describe this? And also, how can we update object in a state? Always return the new state for that, uh, which is to prevent some come of the gotcha when you're working with object-oriented programming. That's why they come up with some principles like solid. Okay, they become solid principles. These fundamentals here as a way to when you're working with object-oriented programming, or as you're going to build object-oriented programs, it's important to have them in this. It's important for us to this application follow these principles, which is single responsibility. If you need to actually create more or extend more its capability from these objects, you is extend that, uh, which is open to extension, close to modifications. And when you extend that by creating some new objects that can have access from the property of the parent class, they must have the ability to replace as the parent class, the subclass, known as the Lizard substitution. And if you want to now provide more and more and more functionality, or you want to do more and more subclassing, instead of providing a huge giant object, you segregate by interface segregation. A good example of that is you have a stove. You know that you have all of these little knobs that allow you to control the temperature for that. So instead of actually you uh, having the full access to your kitchen, all right, it means that you have all of these different cables and tubes that you need to connect to. And this is also the another principle, which is the dependency inversion. You don't want to actually manipulate, you don't care about how that thing is wiring up behind the scenes. You rely on an abstraction, which means that instead of actually you having to, if you have an electric stove, uh, close cables together in a way that actually makes sense to actually turn off the stove, uh, you don't want to do that. In fact, you can, but in fact, it is much more easy for maintain and for build this application by relying on an abstraction. So you don't know how that thing works, or you can know, but you don't care. Different. You don't care how that things work. You just only care that that thing do what it's supposed to do. This is come now with the functional programming. So instead of being imperative, which is when you are in imperative, you're saying, hey, I want you to have full control of what's going on here, which is great. But when it comes to actually build things that are more scalable, it's actually a problem. Why is that? Because you have now all of this full control of all of this. You might realize that sometimes you want is to delegate that as a way to have much more time to solve more complex problems. In other words, you don't want to worry any time that you go to the stuff actually putting those cables together to that's time that take you. You don't want that. In fact, you just wanted to have just a single knob interface that allow you to do that. So by relying on this abstraction, you can now actually do what you want or get what you want. So this is a good example in real life, and then you also apply that to code as a way to say, hey, instead of actually you having to rely on how that thing is connected, okay? If you're connected to a MySQL or a Postgres or a MongoDB, no, you don't care about it. You just care is that you have an abstraction that actually handle that things for you, so you can just get that from that. You can get that dependency from that. And, for example, reset the password. You create a function for resetting the user password. You know, you create a function to get some data, uh, get the user profile data. You know, regardless in which database they are stored. So this is something interesting because, again, this is just solving this particular problem, and the TLDR is like always returning a new state, period. And when it comes to updating arrays, how important is to actually do this with how actually it's important to do this yeah so how actually it's important to do this with your how actually it's important is to how you can now update array in an state. Okay, so for example, you always need to is return a new array state. If you want to add elements, you can do that, for example, at the beginning or at the end, and in the middle you do the spread operator from that of that array. Okay, and the spread operator, what it's going to do is to call is this iterator objects, which is now a very interesting topic here of the JavaScript, where now this iterator concept is now given the ability to, instead of us having to be imperative when it comes to tell how to iterate through all of these objects, we rely on this iterator or iterative protocol that is made of two parts: the iterable, what you define is the iterable logic that is going to be used by the for off loop. Okay, and then you're going to is define the iterator protocol, which is what will be the output that this function that anytime you call it will return, which is made of the next function. That return is a value followed by the DOM property. So the idea here is that when you're using that, all right, as a way to now call all these functions, and actually is so for example, something that they define here, okay, in adding an element like this. No, this is adding an element like this. So what you're telling with the spread operator is like, hey, what the heck? So what you're telling with the spread operator here, like this. So what you're telling with the spread operator here, like this, you are effectively, it's a syntax allow an iterable such an array on a string to be expanded in place where 0 or more arguments for function calls or elements for array literal. For function calls or elements for array literal are expected. In an object literal, the spread syntax enumerates the property of an object and adds the value pair in the object being created. The spread syntax looks exactly like rest syntax. In a way, spread syntax is the opposite of the rest syntax. Spread syntax expand an array into its elements, or expand. When they say expand, it's actually is calling all of these elements. That's what they say, expand an array into its elements, while rest syntax collect multiple elements and condense into a single element. So spread syntax expand an array into elements, and the rest syntax condense into single elements for that. So that's why we have rest parameter like this, which is working in functions. It condenses that, all right? And the other is the rest property, like this, which is expand that. So the idea of this, okay, because what it's doing is to looking at this iterable, allows an iterable such an array or a string to be expanded in places. So that's quite interesting because, for example, if you have a string, when you say, hey, Loren Ibsen, and I know that I'm making a huge tangent here, but bear with me, which is something that you're going to do a lot of the time. And you say in the string, right, string, or demo string, okay? And then you say demo string, and then you want to now spread that. It says syntax error expected expression here. And what it's going to do here is to say, hey, syntax allow an iterable, such as an array of or a string, to be expanded in place where 0 or more arguments for function call or elements for an array literals are expected. So here what you're saying is this. Effectively what you're doing is that I want you to now take this iterable, which is a string, okay, and please expand that into an array. And I think this is something powerful. Why is this? Because how you can now, for example, transform this, say demo string, you can say to array, I mean, you can say is to split, I mean, it's split that. So you want to transform all of these elements like this, which is another way of how you can do that, all right? But the idea here is that it's not only going to work as for string, you know, this is going to work for any iterable objects, whether it is that implement that iterative protocol. It's an iterable where you can specify is the iterative algorithm that will be used by the for of loop, as well as it has the iterator protocol, all right? Where the idea here is that it is made much more meaningful as a way to say, hey, let's say that now demo string is now an array, okay? So for example, we say count demo array, which is this. You know, you have all of this data in this collection. Demo string, okay, is now split like this. So now demo array is as we expected. But the thing here is that, so how can you, for example, can spread all of these elements to other data structures? So for example, if you do things like this, you say, hey, I want you to now is a demo array, all right? So for example here, as a way to transform them like this, okay? So the point of this is that we now have a consistent way of how we can now is based on an iterative algorithm, we can is work with several iterables objects, strings and arrays, which is most of the time what we're going to do. Most of the time what we're going to do. So we can expand this, all right, or we can condense if you're using the rest parameter for that. So, and I think this is quite interesting. And I think this is quite interesting. Yep, this is quite interesting and convenient because not only that, you can say is this. Hey, I would like to add now an element at the end. You know, so instead of actually doing the push, you actually add this single element like this, last. Right? So things are becoming much more easy to work with. What you can is add it at the beginning. You say, hey, let's going to add this at the beginning. Hey, start here. And you can start in all of this. So how you can now do this, you might wonder. Well, you can do that by doing is this. You can do say, hey, this is another method that you can do, another way of how you can do that, by saying is, well, let me now actually is add these elements to the last, right? And when you do this demo array, you actually add that element at the last. Or you can say demo that on shift. You can say start. And you may think, what is the problem? I don't see any problem here. It's like, why are you showing me this? It's like, I don't see any problem. You just showing me is a new particular way of actually adding and removing elements. It's like, what do we have this new way of adding or removing elements? It's like, there is a subtle difference here, because when you do is this, using the spread operator, you are returning is a new array, which means that you are not mutating that array. So for example, at the n immutable or n new state, which means that you add that n new state, but you add that, but you know that your demo array still the same. Why this is important? Because I mentioned before is the solid principle. When you're starting to modify or change or mutate elements here and there, they become problematic. And I know why there is a lot of people in Java. I know why there is a lot of people in Java oof. I know there is a people in Java here.
¿Sabéis una noticia que sí que es realmente interesante? Se nos va una leyenda, pero no una leyenda querida. Yo voy a explicar por qué. James Gosling, el abuelo de Ryan Gosling, no, es broma, el creador de Java se ha retirado. Lo tenemos, por fin se ha retirado, se ha jubilado. Después de una gran cantidad de años como ingeniero de software, es hora de que me divierta. Los últimos 7 años ha estado en Amazon, ha estado muy bien, proyectos diferentes a pesar del COVID-19 y la locura industrial. Tengo una larga lista de proyectos paralelos para ellos va a ser divertido.
So the thing here is that is because those designers, those system designers, that's one of the reasons why you must understand in systems.
Hacer más necesario en Java de vez en cuando, como, no sé, en una de las nuevas versiones, esto, el public class, esta cosa, ¿veis? Esto típico de Java, ahora vais a poder hacer directamente esto. Yo al menos no tenía ni idea, o sea, por fin, default main slash done, mucho más corto, mucho más corto. Fui todo el día de la aplicación, pero realmente tenía que ser como típico Hello World, donde son todos chiquititos, pues como que ahora lo han simplificado. Fíjate, fíjate el tiempo. No sé lo que ha pasado, pero lo han conseguido, lo han conseguido. Ya no tenéis ni que poner stats ni decir, Scorpio default. Lo he conseguido. Lo hemos conseguido, ¿no?
So in any case, the idea here is that when you're able to look at this, and you might wonder, is like, why do we need to return is a new state? Is because th- from the solid principle, is because I, they're now taking borrowed concept from functional programming and say it is much more it is much more easy to maintain an application that always returns a new state than mutating its state. Why is that? Because it can cause ripple effects that you don't know what the is doing. So that's what happened. So that's what happened. That's exactly what's going on and what's happened. So this is the reason why, for example, we have now is properties like to sort it, you know, to sort it, to reverse, to sort it, to splice here as a way to say, hey, just give me is um, to splice from 1 to 5, right? And then give me is a new state from that. Do not modify the current state. And I think that's quite interesting. And I think that's quite interesting. Hey, return me this as an string. And I think that's quite interesting because now a lot of people from the community have learned the hard way that mutating objects can cause rippling effects, undesired ripple effects, and it is much more easy to work with new states that generate is a new state despite that is actually use much more memory. But when it comes to actually is yeah, despite that it initially can consume more memory, but when we don't use that reference anymore, we can delegate that to the garbage collector or any other mechanism that is capable to actually see in our draw, hey, this thing you're not using it. I don't have any reference for this. Like, get out of this. Okay, that's quite beautiful and interesting. Uh, so, and also the reason why, for example, updating in the state, we now are capable, or using the spread operator, we are capable to add items at the beginning or at the end, or if you want to actually remove one element from that, you say using the to find, hey, I want you to now evaluate all of these elements here and return those that satisfy this condition. In other words, like, hey, if they are different, if they have different ID, give it to me. If that has the same ID, discard it. So this is something that, for example, here by replacing items using, I mean, is on deleting items or removing items from that. The using is that filter as a way to do that, and how the filter returns is a new state for that. You can also look at the transforming array to apply something that replacing items in the array, inserting into an array, but the whole point of this, okay, items before the insertion point, adding dot slice like this, and you're actually going to generate a new state from that. with the spread syntax, because it's only iterable values from that. So for example, functions, in function arguments, or array literals or object literals. Okay. As you can see here, which is a more powerful array literal, spread in array literals, something that they are mentioned here. Even though we can do is something like this. You can say is inserting into an array. If you want to insert that items before the insertion point, you say earlier. Okay, as a way to indicate at which position do you want to add this element. That makes sense. Items before the insertion point. As a way to where would you like to add this element here. You know, pretty much like now showing is per priorities. Items before the insertion point. Could be any index. Exactly. Another interesting thing here is to inserting into an array. I talk about is how you can insert items at the beginning or at the end, which is most of the time how you can do that, or how you can now specify where you want these elements to be added using the slice from that. Okay, so items before the insertion point. So pass all of the items before the insertion point, and then add that element at that position, followed by the others. An insertion after the insertion point. So this is quite interesting because now you can specify at which position you want to add that element. In this case, it will be 1, 2, 3, 4. I think it'll be here. Oh, 0, 1, 2, 3. It'll be right after Lamidi. Oh, okay, because now you exactly. Yeah, you mess up this. It can be, for example, like this, 0, and like that. So you're gonna add that at that position at 1, 2. Interesting. But again, the idea is that you can actually do that, and also to reverse that, giving a input here. So this is quite interesting as a way to now look at and be able to describe what's going on here with the spread syntax. So copying an array here is doing is a shallow copy, which means is that shallow copy is it only have is a copy whose properties share the same reference, point to the same underlying values, and as those to the source object from the copy was made. As a result, you change either the source of the copy, and you might also cause the other objects to change too. That behavior contrasts with the behavior of the deep copy, in which the source and copy are completely different. In this shallow copy is going to now reassign top level property of the copy does not affect the source object, but reassign nested object property affect the source object. So this is again something quite interesting to know as a way to dive deep into this, deep copy and shallow copy. So in other words, this shallow copy, what it's doing is that top level reassigned properties are not reflected, does not affect the source objects. But nested objects, reassignments, affect the source objects. So the idea here is to now at least being able to create a new state here. Okay. Yeah, be able to create is be able to create is a new state. Sorry. Be able to create is a new state, top level of your object. Okay. So in any case, then we look at how can we manage your state, something that I'm now quite familiar with because this is where I have the most experience here as a way to, once you know how to describe a UI, adding interactivity, it is time for us to say, okay, how can we now is managing the stating of React components. That's a way to prevent any of the bugs that happen on the state, how by looking and understanding is a state structures, keep up the update logic maintainable, and how can we pass data to different components, we can now is scale this UI. So first we look at how can we think how to how we look at how to think in how to think. Okay. Is like how to think UI state as state change. And this is just by looking at how the UI designers actually created wireframes by creating all of these visual different states. And then we, as React developers, how understand what triggered those state updates, okay, as a way to now represent those states with new states in memory. And then we connect the event handlers to set the state. This is pretty much what we're gonna do. And this is the way of how you can now declarative describe your UI. Okay? And we also look at the importing of that instead of the imperative. I mentioned why we don't use imperative, even though that you can, depending on the use case. But again, React now is giving you this descriptive nature of what's going on here. And then when it comes to, this is what just to describe the UI inputs or how to think UI state as state change. And then we look at how can we organize our state by providing a structure given by React community, by when they say group as a way to take for borrowing this concept from the database engineering, when they say for taking borrow this database concept like normalization, which is eliminate redundance or duplicate data, okay, and how with that we're now also able is to and with that we were also now able is to see these principles like, well, group state, group related state together, avoid any contradictory states, avoid any duplicate states. Hey, because it is hard to keep sync, avoid any redundant states. Can I get this data from its proper from its state, as well as the avoid deeply nested object in your state, because now making that state update logic is quite verbose. And then a look at how you can now is giving that state share across different components, and by also looking is at how to think in terms of React by saying first you must start with the mockup and the data, and then you're going to break up the UI into UI components hierarchy, then create is a fixed or static React version of that, and then figuring out the minimal but effective UI state representation. Okay, so what'll be an state and what doesn't. So pretty much, if that data doesn't change over time, that's not a state. If that information that you can get comes from its props, that's not a state. If you can compute that data from its state or its props, that's definitely not a state. Whatever left is an state. So then how you can now is looking at this, for example, this is that how you can identify where your states should live, which is now this is the part of this is where we are saying, okay, yeah, this is where this is when we say, all right, where which components or each unique piece of state you will choose which components owns it, which means that identify where your state should live. So with that, the idea here is that these components will act as a source of truth of all of these other components. And this is when now concept like Redux kicks in and say, hey, we're going to help you organize your app level state data in this centralized place, where now any components that want to have access to that can just read that, or if they want to update something, they can do that. So whether it's dispatch and actions or read that through selectors. And that thing started to makes a lot of sense once you understand that and what is the value proposition that you can come up. So, but in any case, as we now understand that and how when you identify where which unique piece of state should live or should own that, then it is time to add the inverse data flow. In other words, is to say, okay, now I'm going to from the child components pass, or from the child component be able to not listen to or be able to receive that props that I want you to update if I need to as an state, followed by the handler, okay, which is now what I'm going is to emit, or what I'm going is to trigger in the child components. This inverse data flow here, and they call this inverse data flow here, which is part of this. You can learn all about handling events and updating state and adding interactivity. But this add inverse data flow is something that you're gonna do a lot. It's something that you're gonna do a lot. Because now in the search bar, we're gonna receive that unfiltered text change is when you actually path that. Hey, now this is what I want is to do this. Set filters text, okay, and unfiltered text change, which is something that we're passing here. This is what we're gonna do here, and then pass down data to that. So this is now as add inverse data flow. So you're now going to define your states, and then on the child components, you're going to define as the handlers for that, or the state updaters from that. So that's quite interesting, because once we're able to understand that and how important it is to describe, and as this is not a technical term, but it's important to understand that this comes in when they mention in terms of your components, uncontrolled and controlled components. Uncontrolled is those components that information is owned by the state, okay? The uncontrolled component, as they mention here. Da, 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 da. Yep. Exactly. To see what this feels like in practice with a few more components, read the thinking in React. Control and uncontrolled components, like this. So in practice, control and control components are in strict technical terms. They just allow us to, when you're going to write or when you're going to design your React component, how useful it is to think in terms of its capabilities. So when writing a component, which information in it should be controlled via props, and which information should be controlled via state, uncontrolled via state. But you can refactor that. It's common to call a component with local state uncontrolled. Okay, so if you have a component that only has some local state, call this uncontrolled, because it now can hold is all of these configurations object. So for example, the lineal panel component with an isActive state variable is uncontrolled because its pattern cannot influence whether the pattern is active or not. In contrast, you might say a component is controlled when its important information is driven by its props. So again, perhaps this is not a strict term, but it's helpful when it comes to define your components. And not only that, is that when you define your components, how useful it is to understand the most of the time is when you define your local state here, okay? Yeah, when you define your local state here, they call that uncontrolled components. And when the primary information is driven by its props, they call this a control component. And again, all of this terminology can shift on that. You can also refactor that. But the point of that is this. Then we look at how can we preserve and reset the state, and how now the state is tied to the position of the rendered tree. Therefore, if React behind the scenes, what it does is to preserve is the state of the same component at the same position. Okay, if they have different component at the same position in the render tree, so what it's going to do is to reset those states. If you want to reset the state of the same components at the same position, you can use or rendering a different position of the tree, or adding a key, so now React can identify this as a unique element, and therefore it's going to reset the state, giving a data. As well as you're reacting to more and more as you need to, or the more input you need in a state to react. The more input a state needs to react, the more sense it'll make to use a reducer, because of the reducers help to keep our state update logic maintainable. How is do that? By creating a function here, using a reducer function, a reducer hook from React, where in the first argument you're going to pass is the reducer, which is a function that takes a state and an action and return a new bit of a state, okay, that indicate now React based upon that action object that you pass when you dispatch that. in your event handlers, okay, what'll be the which one of these uh, inputs you want to uh, which one of these inputs you want to react, and therefore update the state. So that's quite interesting, because knowing this and what's going on and describing that thing is something that is helpful for you, as well as to understand how the things is working. And then the second parameter of this call of the hook is when we're passing is now the initial state. So all of this is in theory, and when it comes now to pass data to distinct components, okay, whether it is grandchild components, you use these things called a let me see, yeah, you use these things called is a yeah, you use these things called is context as a way to now solve this particular problem, now as prop drillings, where you create a context and then you use that context using the use context hooks in the component needed, and then you provide that data uh, to those components that needs to. So it is tempting to overuse this context, but before that, or pass your data through props, or extract that component into a GSX so you can now pass that data. If you can, well, go with context, but there's some specific use case where context is helpful as a way to make your components to adapt to your surroundings. For example, to show the proper theme, okay. So for theming, applying is all the necessary styles when change the theme. The other is for analytics, okay. When the new user actually get in, you actually get all of the data from that, as well as for authentication, okay. And 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 um, yeah, and what else? And for example, also the browser, React Router browser actually use context behind the scenes. And when you want is to now make your state update logic with reducers maintainable using a context, when you define is an state inside of that, aka scaling with reducer and context your statement. So how can you do that? You define is the context for the action, you define the context is for the state and for the dispatch, and these function and then you return a function where you're gonna is to define is the state using the used reducer, okay. And you're going to define is the reducer function right after the function that you're going to return that is going to contain is the providers what you receive is this children's and the you return is the children's for that, as a way to now make those as a way to make the sub-tree components as a way to make the sub-tree components aware of this context. And if they want to, for example, dispatch that information, they can use the context followed by the dispatch. So the problem with the context is that now every time, so React will re-renders any child component that use a context starting from the provider that state or that value change. So it can be quite problematic, and that's why we have, for example, optimization techniques like inside of your context, if you define some functions, let's go to now is wrap them into a use callback as a way to save, as a way to catch this function reference between renderings, and the other is the use state or the memo, all right, where now on the memo it allows you to catch its computations during re-renderings. So with that, we can now prevent our reducers to be, or to our context to be rerun, therefore call all of these React components that use that context when that context is rendered, when that value change. Uh, and that's it. And that's it. You know, that's pretty much with that. And then we look now at the escape hatches as a way to see how can we now control and sync with external systems. This is actually pretty interesting. We look at how can we remember information, and I think this is important to describe so you can later on then apply some more specific terminology. But it's important to start with the basics and then with the specific. So here we look at how can we now synchronize with external systems and control external systems to cover specific use cases. So for example, input or focus on input using the browser API, or interacting, place and resume the video player implemented outside of React, or simply just is connect to a remote server and listen to events. So first we look at how can we remember information between re-rendering using .ref, and how .ref is the secret pockets that allows to store this information under the current objects. You should not use that for during re-renderings, and this is a very specific tool that we can use for timeout IDs, getting or manipulating DOM elements, or any objects that we can store that is not affected during rendering or during GSX evaluation. So we look at how can we use that for our timers as a way to clean up our timers when we react to an event, when we're responding to an event. Okay, and then also we look at how can we manipulate DOM reference with that, and how does the useRef fits in the entire mechanism, because now useRef is defined. So now useRef is defined after the rendering phase and set to null, and then is assigned to the proper DOM element or to the proper reference after the commit phase. And this is something important because this actually will lay down the foundation of what's coming next, which is how now you can synchronize with external systems using effects. And with useRef, we look at how can we now working with is for sizing the screen, or for scrolling, or for focus the input with that. And now with useEffect, which is unlike events, it is important to understand what is the logic. What is important to understand is the two type of logic in our React components. which meaning is, well, you got now the rendering logic doing the function, describing the UI, okay, and this must be pure, and the other is the event handle logic, which inside of this is what you can define is your async operations or your side effects. So this use effect or is when you can perform side effects that are caused when these components re-render itself. In other words, you can now run this piece of code, this side effects that is caused by rendering itself. So, and I think this is quite compelling, quite interesting, that kind of thing, blah, 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 blah. So, we look at, now that we know that distinction and when the use effect fits in the entire rendering mechanism, the React team decided that the best place to actually run all of this code is after the commit phase. And by default, this code will run after every commit phase. You know what I mean? So there's also a reason that you should, there are, for example, there are example that tells you, it's like, hey, you shouldn't need to use a, you shouldn't need to use an effect. But you might not need an effect, especially if you are not, if you don't need to synchronize with external system, you might not need an effect. And because we look at how can we write our effect and understand is the logic behind the scenes, because as Brian Hall mentioned, is that this was caused, if you want to have a happy life as a React developers, so don't use effect. This is a loosely coupled here, that don't use effect. Don't use effect. Because most of the time effects are being used to, for 95% of them are used for API calls. Okay, for that. If you really need to use an effect, then try to self-contain that into that. Therefore, it's like, all right. That's why, for example, we have other solutions like React Hook. We have other solutions like React Hooks as a way to help us is to we have, for example, React Query as a way to deal is with this data fetching, catching, in sync with the server side. So that makes a lot of sense to rely on this other, perhaps, third-party servers that actually are very, very good at what they're doing. Okay, and so you have now React Hooks. React, is React Query. Okay, and they create this React Query because, again, effects primarily you're going to be used to synchronize with external systems. 95% of the time is to actually perform API requests. If you're using an effect for something else, for something different from that, I'm going to be very, very annoying of why you're doing that. Exactly. But this is now the text version 5. When they say, okay, so let me actually use this. And how you can use is a query here, React Query for that. Even in your next page. Because this is makes something much more compelling than that. It's making way, way, way much more compelling here. The header, the info box. use posts exactly like hooks. Here where you can define your reusable logic here. Like that, use post and fetch post. And then you got the entry point for your application, where we climb like this, and then you define is a climb provider using context. Okay, so we do have now this data centralized here. Also is here height rotation boundary. I think this must come from React time stack. Exactly. Totally. Height rotation boundary, query climb provider, and component. Okay. Yep, and components like this. So what you're gonna pass down is the page prop as it is from my app. So that's quite interesting. This is the client only code. This data is loaded on client and not prefetch. And this is what it's going to do. This page show how to use static site generation with React query. Yeah, that's one of the reasons why I love to use is React query. However, if your application, because even though in this example, if your application is already using Redux, stick to Redux. Stick to Redux. Stick to Redux, man. Stick to Redux. And not only Redux, it's to Redux Toolkit. It's to Redux Toolkit. That's right. Stick to Redux, especially to Redux Toolkit. Okay? And go and stick with the RTKey query overview here. Like so. As a way to, well, data fetching. Eliminate, exactly. React query is a powerful data fetching and caching tool. Data fetching and caching tool. It is designed to simplify common case for loading data in a web application, eliminating the need to handwrite data fetching and caching logic yourself, aka create your own hooks for that. RTK query is an optional add-on included in the Redux Toolkit package, and its functionality is built on top of the other API in Redux Toolkit.
Understand the basic data flow of list details for dogs. So let's take a look action. Our application either shows us details for a selected Pokemon or the list of Pokemon. As this is not about a router library, we don't have a router, but we just have a state which contains the currently selected Pokemon. And we have the Pokemon list component. This just takes the fake Pokemon listing data, displays a list starting at 1 right now, and for each of the Pokemon we have, we display it as a button, and if we click it, we select the Pokemon, which will in turn set the selected Pokemon, and which will in turn
The inverse data flow.
select the Pokemon and get some of the Pokemon details. In the Pokemon details, we also take the fake Pokemon detail data and display it, the name, icon, ID, height, weight, and we list all the types of Pokemon.
So over the last couple of years, the React community has come to realize that the React community has come to realize, hey, data fetching and catching is really different. Is really a different set of concern than state management. Data fetching and catching is a different concern than state management, because one of that you have to organize is your state, okay, how you can keep sync of the state, and the other is that how you can catch that state, or to fetch that state. While you can use a state management library like Redux to catch data, the use cases are different enough that it's worth using tools that are purpose built for the data fetching use case. That's what you have, for example, React Saga or Redux Saga, an intuitive Redux or side effect manager. Redux and Redux Saga. That makes a lot of sense. That makes a lot of sense. That makes a lot of sense. This is an intuitive Redux side effect manager. Side effect manager as a way to run code to synchronize with external systems. Initiate a side effect, connect to the store, and connect to the store new version. Asynchronous. ES generator make asynchronous flow easy to read, write, and test. Create complex side effect without getting bogged down by details. Saga enables numerous approaches for tackling parallel execution, task concurrency, task racing, task cancellation, and more. Keep total control over the flow of your code. Easy to test. Assert result at each step of the generator or for a saga as a whole. Yeah, I get it why Fungal Master is doing that. Mm-hmm. 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 Redux. Redux Toolkit for efficient Redux development. Copyright 2023. Built with Dr. Cyrus. Mm-hmm. 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 Yep. Mm-hmm. That's very, very interesting. Synchronizing with effect. And then we look at how can we declare our effects. So first by declaring is the effect that initially it will run after every commit. Okay. So by passing is an array of dependency, since you don't want to this code run after every commit, okay, you specify is an array of dependency that say, hey, only when those dependency change, I want you to now run this code on after the commit phase, or after every commit, when those dependencies change. And then the cleanup phase. That, for example, if you're connecting to an external system, you also need to disconnect from that. For example, if you're connecting to a remote server, or you're subscribing to an event, or you are adding an event listener, and then you want to remove that as a way to release memory, or for fetching data or sending analytics. Holy moly. Okay.
¿Qué? Ojo, que eso es otra provincia.
Sí.
Por eso, es
Por
otra
eso.
nación, entonces bueno,
Claro.
están utilizando ahí plata de los chinos para que la gente no se vuelva loca.
Sí. Información encontré nada, otro mundo. Iba a ver cómo iba a afectar las palabras de este tipo el día de hoy, pero tengo otras cosas más importantes que hacer.
Vivo en Caracas. Ah, no,
Ah, él
sí,
quiere
va.
ver cómo es su cumplimiento. Ah, ok. Ya votó como que casi que la única persona que conocen de Venezuela, aparte de Dross, a Chris Bullock.
¿Voto?
Sí.
Ah, ok. Ah, porque esto no es rural. Mm.
Por favor, no soporto más.
Lula estaba promoviendo en el G20 cobrarle impuesto a los más ricos. Hacer un impuesto global para cobrarle a los más ricos, así.
Pero si los más ricos son los políticos, man, o sea,
Uno de ellos son los más ricos.
que se jodan todos excepto yo.
Si se vuelven los más ricos, se vuelven los más. No, y Estados Unidos le dijo a Lula, no, eso no procede. Alemania también dijo que no, eso no procede. Esto es una vaina recha, porque. Ay, o sea, en fin, o sea, al fin y al cabo, marico, tú tienes que alinearte a las cosas de la naturaleza.
Eso se necesita más gente, ¿no? O sea,
Tienes que alinearte a las cosas de la naturaleza. Y
gente
las
que
cosas de
no
la naturaleza es
piensa.
que tú tienes que producir, marico. O sea,
Gente que no piensa, ¿no? Gente que piensa como que,
tú tienes que producir.
que la plata es como que un numerito mágico que tú puedes cambiar en un sistema, ¿no? Weón.
Lo que pasa es que cada quien tiene opiniones diferentes de cómo administrar, ¿no? Cultivar el suelo es servir a la patria. sería lindo, sería ideal.
Si tuviera el super servidor fácil.
Sí,
Sí.
sería ideal. Yo genuinamente yo haría eso. Tú tienes política y falta de experiencia en eso.
Al fin y al cabo como que es lo que uno necesita para vivir. Siempre como que lo que más valorado está. Sin componer tampoco controla a la gente.
De acuerdo.
Si no, que te lo diga Cuba, Venezuela.
Bueno, aunque Holanda es un caso particular porque ellos como no tienen espacio ni tierra, entonces han decidido es sembrar, hacer los gallineros verticales.
Mm.
Pero igual. Lo que pasa es que también Milei utilizó esto también como para dar un, aquí está todo es un show aquí en España.
Sí.
Como en Venezuela está en la elección, yo también lo voy a hacer aquí, voy a dar un discurso aquí de lo que he hecho. Marico, hazlo y ya, no sé, lo que querías
Por
ver.
ahora.
No, yo no los llamaría desarrolladores. Al lado.
Desarrollados pero muy mal gestionados, diría yo.
Sí. Técnicamente desarrollado, pero mal administrado. Porque a nivel cultural, bueno. Eh, Tampoco los marroquíes o la gente del norte de África ha querido integrarse, ¿no? Entonces como que, bueno,
Los marroquíes son los de unos venezuelanos de Europa, ¿no?
y no se han querido integrar, entonces como que, bueno, que mira como Johncito, deportado de Estados Unidos. El berecón que estaba en Nueva York y que,
Ah,
¡sí! ¡Aquí estamos, mi pana! ¡Ah! Y así, tipo pidiendo plata por ahí prestado, yo soy como que verga. Ok. Ay, qué pena con la visita. No. Es su madre, bueno. Pero sí. Ay, se están enfrentando ahora los de marroquíes y venecos allá, marico, en Madrid. Sí, marico, y yo, ay, ya, yo honestamente yo con los marroquíes no me metería.
eh,
Porque,
llegaron a haber conflictos, que yo sepa.
sí, sí, sí,
Sí, sí se dan duro.
sí, sí. Yo con los marroquíes no me metería. Uno porque ya tienen años, si no décadas, tejiendo entramado. Venezolanos tienen apenas qué, un par de años ahí. No, no me parece como muy sabio, que digamos.
Aunque, claro.
Pero igual hay que tratar de, en la medida de lo posible, llegar a un acuerdo con esos jefes. Lo que pasa es que la mayoría de esos acuerdos terminan siendo como los círculos bolivarianos.
Sí.
O sea,
Mm.
o sea si no los integras a la economía y no le dices, mira, esto es lo que tenemos que hacer, no puedes vivir de nosotros, ¿ok? No puedes vivir de lo que papi y Estado te den, y sin pensiones, entonces, no, los servicios, ni
Pues,
programas
sí.
sociales, no.
Ahí yo meto la mano en el fuego como que por el gobierno y digo como que tipo, ok, pero yo estoy como que con una persona, negociando con una persona que puede tener la plata rápido, jodiendo, robando, en comparación a alguien que se tiene que mamar, digamos, un solo incremento o que tenga que estudiar
poniéndome en carne de ellos, yo como que obviamente me sale más rentable robar y joder gente, ¿no?
Claro.
Sí.
Sí. Estamos hablando de comercio, de capitalismo, sí.
Sí.
Me sale mucho más rentable. Oh, shit. Fuck.
Yo estuve hablando de eso ayer con mi primo, pues,
Qué fuerte, sí.
marico, mi primo, tuve como que una de coincidencias que te lo comenté, mi hermana y también mi primo que está viviendo en México,
Ok.
que no le está gustando cómo está la vaina allá, que se está poniendo muy peligroso, muy violento,
¿En qué parte?
en Monterrey.
Y eso que no es una zona tan peligrosa.
Sí, pero acuérdate que México es una cosa, bro.
Esa es Venezuela, es un Estados países.
Y eso a él no le está gustando, entonces él le está comentándome que, verga, weón, aquí la vaina se puso jodida, jodida, jodida. Si bien tenemos poder adquisitivo, ¿de qué coño la madre sirve tener plata pero no poder disfrutar de ella saliendo un ratico a disfrutar porque te ponen un toque de queda tipo a las 5 de la tarde hasta llegas y si no te matan una cosa así de turno, pues.
A la verga.
Sí, cierra.
Bien, de Monterrey. Demonios. Ok, no estaba claro. ¿Dice Monterrey? ¿Qué Monterrey?
Estuvo diciendo que el PIB, el narco forma parte del PIB de México, está en el tercer lugar. El primero es el petróleo, el segundo es el turismo y el tercero es el narco.
Ajá. Petróleo y turismo.
Yo le dije, bueno, chamo, cualquier cosa. La vida es un intercambio, un equilibrio. Allá tendrás como que mayor poder adquisitivo en comparación a Argentina, pero vida no tienes. Acá tendrás vida, pero plata no vas a tener. Escoge.
Choose your player.
Lo mismo le dije también a Dani, mira, si bien allá tienes como que alto poder adquisitivo, estás viviendo para trabajar y para vivir al siguiente mes.
Monterrey, Nuevo León.
Le dije como que...
Ay, pero es que mira Monterrey. Uf. No, amigos. Todo lo que es la zona norte de México, eso es tomado por los narcos.
Sí, sí, de todo lo que es Chihuahua, Sinaloa, todo eso está narco, man. Eso es narcotado.
Sí, en Sinaloa, Durango, Monterrey. Sí. Ahora, todo lo que está por lo menos en Guadalajara, la cosa cambia un poco. Igual, sigue siendo menos territorio narco. Y en Ciudad de México sí la cosa ya es diferente. ¿Y por qué no estaba en Ciudad de México?
Ciudad de México es caro.
Es calor.
Es caro.
Bueno, pero tiene seguridad, ¿no? Si es lo que está buscando.
Tienes que buscar trabajo también allá.
Ah, ok. ¿Él en qué está trabajando?
De ingeniero civil.
Pero sí es más difícil, está más complicado.
Sí.
Sí, eso es más complicado.
Él dijo que, tipo, mientras estaba allá, conoció a una chama argentina que es de Rosario, que trabaja en Dock Sud. Que si bien Dock Sud es un barrio jodido, 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 hay como que trabajos de ingeniería ahí. Siempre y cuando no te quedes ahí todo fino, pero trabajo ahí.
Dotsuri.
Dock Sud. Los muelles de carga así del puerto. Empezando así como que cruzando el puente de la Noria, yendo de Pompeya a Avellaneda.
Ah, pero eso es Rosario. Donde ellos están.
No, no, Dock Sud es aquí mismo en Buenos Aires,
Ok,
saliendo de capital.
ok.
Yo le dije, Buenos Aires es una ciudad cara y te va a costar en un principio adaptarte, pero si es por temas de discriminación, porque que te van a joder porque eres venezolano, que no te van a alquilar porque eres venezolano, eso no va a pasar. Aquí la gente lo que interesa es que tengas plata.
Listo.
Y yo sé como, ¿qué? Pero si tú acabas de llegar, y tú, ¿qué tienes que sorprender? En Estados Unidos tú no votas hasta que tú no, eh, hasta que no seas nacional. O sea,
Nada de green card, nada de eso.
nada de
Ciudadano.
exacto, tú eres ciudadano y votas aquí. Tienes la posibilidad de votar. No es que una residencita, no es que estás aquí por 3, 4, 5 años, no, no, no. 10 mínimo. Eso me pareció súper descabellado.
Sí. Yo, bueno. Ya a la chamita ya le hablé, yo le dije como que yo no perdería más el tiempo, vayan moviéndose, tienes a tus dos hermanos acá.
Hey, ¿cómo está? Leo.
Bien, dejando que la jeva lo pisotee.
Ah, entonces está como,
Uh,
como desarrollando su personaje. Desarrollando su
uh,
carácter.
bueno, me sale maleta nueva.
Que se rompió.
Sí, se rompió. Bueno, la nación tiene descuentos con Samsonite y American Packer. Igual, desde hace mucho tiempo yo quería deshacerme de esta vaina. La maleta la veía muy cara. Me sirvió en su momento para venir para acá, pero ya
Lo que soñó con cierto.
se descoció.
Ah, pero eso lo puedes mandar aquí a una armeria.
Sí.
Y ella te lo puede coser. Y te va a cobrar, no sé, ponerle. Me cobró por coserme la entrepierna del pantalón, 3.500.
Vale, vamos a ver.
Y está aquí mismo, aquí en la más clara. Está por Blanco Encalada. Está, sigue derecho por aquí por Molde.
Ujú.
Está, ¿sabes que está ahí la comunidad de Rappi?
Sí,
Bueno, la cuadra que sigue más allá de Molde, por donde está eh, los judíos,
sí,
bueno, a la esquina, ahí justamente está ella como tal.
sí. Igual no es como que la gran cosa. Puedo llevárselo y que lo repare, pero esto ya como que para viajar internacionalmente no. Puede ser nada. Confía en la Fuerza Armada Nacional, ¿vale?
do it. All right. How's it going? How's it going? How's it going? How is it going? What are good alternative to data fetching in effects? As I mentioned before here, we looked at yesterday for that. React Query, even though that they recommend that. React Query, that's interesting. For popular way of data fetching, they don't mention is even Redux here. That's that. And how you can even combine with the intersection and observer here. Not an effect initializing the application and buying a product. Putting it all together. So this playground can help you to get a feel of, okay, this playground can help you to get a feel for how effect works in practice. This example, you set timeout to schedule a console log with the input text to appear 3 seconds after effect runs. Okay. The cleanup function cancels the pending timeout, starting by pressing mount the component. So there is something also important to know when you're evaluating this use effect. It's because on the initial rendering, it's going to evaluate is the setup function, okay? Exactly, it's going to evaluate is the setup function, and during re-rendering, it's going to now first run the cleanup code, and then there's the setup function, and then the setup update. Cleanup or the cleanup code with the previous state, and now with the setup function. Okay. So what it's doing is that mount the component. Initially, it will call this and show this. All right. It will say, "Hey, I'm going to run the setup function first," and because now effects, especially if you're using the strict mode, it also called your yeah, it also calls your setup, cleanup, and setup sequence. Most of the effect you will write will fit into this common category. So in production, you will only see is the connecting. Exactly, because on development, what it's doing is that on development is now calling your setup function, setup, cleanup, setup, but on production, you only run is the setup. This is part of the strict mode. Okay. So this is not the setup function here that is being run. Setup, cleanup, setup, okay? And wait, what? Okay, and after 3 seconds, okay, you reset this. You're gonna now run is what you have in the text. Setup, cleanup, setup function, and after 3 seconds, you're gonna get that. Okay? So if text is updated, it will run now the cleanup function first during re-renderings, and then the setup function. So for example, you say this, the hell, it runs the, exactly, it runs now the cleanup function, and then the setup function, exactly, it runs the cleanup function with the previous state, all right? With the previous state. Okay, with the previous state, my question is that, do you have here is the timeout ID? It's interesting, but with the previous state of not only the text, but also with all of the data that you define here, all of the variables and functions you define here. That's interesting. That's very, very interesting. That's very, very interesting. So in other words, it's like, so use effect here, when you have this as a way to synchronize with external systems, whether it's our GSet widgets, jQuery, or maps, or subscribing to events, for example, add event listener, window add event listener, or remove event listeners. You want to fetch data fetching, okay, and how we now react, promotes or give us to, and how React now give us to this way of how can we now access to uh, to data fetching this library like SWC or the React query and that kind of thing. Makes a lot of sense. Makes a lot of sense. Yeah, makes a lot of sense. Uh, and also how we can send logs or send analytics here using is the interceptor, using the interceptor of servers. And not only that is that this is now the most this is what this is the typical or this is most of the effect you will write will yeah most of the effect you will write will fit into these common patterns. That's what happens. Most of the effect you write, most of the effect you write typically will fall into this pattern, and that is, uh, synchronizing with non-React components. So, for example, like widgets, okay, subscribing to events when you need to add an event listener, and then on the cleanup function you need to forget about that. Uh, yeah, subscribing to events, triggering animation is very, very specific to that. Triggering animation for that. Trigger the animation, and then you're going to reset to the initial value. And how now on React, on the development, because this strict mode is not only running your application. So React, the strict tag in React allow you to prevent some common gotchas. So for example, rerun or re-rendering your components as well as rerun your effect. Okay? And instead of actually how can I get rid of this, you can think of this how to fix my effect so that it works after remounting. So even though you might have some bottleneck or it can be, so in development you will see to fetch in network tab. There's nothing wrong with that. With the approach above, the first effect will immediately get cleaned up in its copy of getting nor for that. And they tell you is that what would you like to do as a way to improve the development experience in that particular case, which is fetching data. Sending analytics is another one. Sending analytics. And sending analytics using is now the Observer API as a way to do that. So, because we look at the anatomy of the use effect, just use effect, right? Use effect anatomy here. And that to me was quite interesting. And the anatomy here is that there's some caveats. Use effect is a hook, so you can only call it at the top level of your component on your own hook. If you're not trying to synchronize with an external system, you probably don't need an effect. When strict mode is on, React will run one extra development online setup cleanup cycle before the first real setup. This is a stress test that ensures that your cleanup logic mirrors your setup logic, that is that it stop or or undoes whatever the setup is doing. If this causes a problem, implementing the cleanup function. How to handle effect firing twice in development. The other is that if your effect wasn't caused by any, exactly. If some of your dependencies are objects or functions defined inside the component, There is a risk that they will cause the effects to rerun more often than needed. To fix it, remove unnecessary objects and function dependency. You can also extract state updates and non-reactive logic outside of your effect. If some of your dependencies are objects or functions defined inside of the components, defined inside of the rendering logic, there is a risk that they will cause the effects to rerun more often than needed. To fix this, remove unnecessary objects. Oh my god, no. What is it? No. Remove unnecessary objects. Okay. Remove unnecessary objects and functions dependency. You can also extract state updates, which is on the use effect, and non-reactive logic outside of your effects. But again, this will cause that your effects, this side effect code that will run after every rendering, after every commit phase, as long as this dependency change, it will make you run that. So for example, like this. Okay. It will cause that this will get triggered by that. So you will constantly evaluating this use effect here on every re-render. Okay. But it will get re-rendered. So on every re-rendering, you will have is a different. That's what happened on every render. You will have a different. Okay. Thus, or ID thus or ID holds a new reference The watch method is designed to efficiently track form field values without causing unnecessary re-render. It typically returns the same reference if the value hasn't changed. This effect suggests that ORID is expected to change sometimes, triggering the effect, which is triggering is this piece of code, which is this. And again, because now this will prevent re-rendering here. Okay. Exactly. If the ORID exists, okay, now you're gonna make is this. You're gonna run this go after the commit phase, as long as the ORID change. and you're gonna set the value of that for that, because now you are, I'm assuming that you are some form here, and you attach that form. Exactly, then you attach that form to that. Form control, form control, form control. The accordion. Mm-hmm. 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 Okay. Mm-hmm. So that's what happened. But again, this is the anatomy of the use effect. Is that so? By actually looking at that, this will only change as long as that component gets re-rendered. But because this is part of a hook, does this hook cascade? Okay, when this hook is okay, when this effect is run, and does this cascade into another effect here? Mm-hmm. If your effect wasn't caused by an interaction, React will generally let the browser paint the updated screen first before running your event. Okay. So if this was caused by, okay, if this wasn't caused by an interaction like a click, if your effect is caused by an interaction like click, React may run your effect before the browser paints the updated screen. This ensures that the result of the effect can be observed by event system. Usually this works as expected. However, if you must defer the work until after paint, such as an alert, you can use set timeout. Even if your effect was caused by an interaction, React may allow a browser to repaint the screen before processing the state update inside of your effect. Mm-hmm. But if your effect wasn't caused by an interaction, React will generally let the browser paint the updated screens. Okay, so paint the screen and then run your effect. Paint the updated screen first before running your effects. If this wasn't caused by an interaction. Okay. And effects only runs on the client. They don't run during the server. So by looking now at the anatomy here of what actually is doing, connecting to an external system like this, okay, connecting to an external system, listening to global events, triggering an animation, controlling a model dialog, tracking element visibility, okay, wrapping effect in custom hooks, like so. So effects are an escape hatch for that. So here this describing is controlling a non-react widget. Okay. Wrapping effect in custom hooks. Controlling a non-react widget, fetching data with effects. This ensures your code doesn't suffer from race condition. What are good alternatives of data fetching in effects? Is React query and that kind of thing. Specifying reactive dependencies. Every reactive value used by reactive dependency. Specifying reactive dependency. Reactive dependencies. You need to prove to the linter that it doesn't need for to be a dependency. Now that the server is not reactive value and can change on a re-render, it doesn't need to be dependency. If your effect code doesn't use any reactive value, its dependency list should be empty. Okay, updating a state based on previous state from an effect. This is known as batching. Removing unnecessary objects dependency. Reading the latest props and state from an effect. Yeah, reading the latest props and state from an effect. Use effect. If you want to log to new page, visit after URL change. But now if you only shopping displaying different contents on the server and the client. Display different content on the server and on the client. Set did mount true. Okay. But understanding the anatomy to me it's like okay. So now by looking at this structure or of the anatomy, by looking at the anatomy of how you can connect to external systems, which is you have using an effect, where the idea of looking at effect is that first you need to understand what the type of logic that you have in your component. You have a render logic and you have effect or using or event handler logic. Your rendering logic must be pure and your event handlers can perform nice side effects. So when you need to run some side effects caused by a re-rendering or caused by rendering itself, That's when you have use effect. And use effect is allowing us to run this side effect or this piece of code after every commit phase. So most of the time we don't want to do that. We just want us to run that piece of code based on some dependency. That's why we pass this as the second parameter, this array of dependency. And more often than not, more often than not, is that once we pass this state, okay, that makes a lot of sense. That makes a lot of sense. That makes a lot of sense. Oh shit. That makes so once we define this side effect or this piece of code here, okay, then we'll be able is to based on the array of dependency, now trigger this effect. And how this code is being run, especially if you are integrated with external systems, when you need to also is unsubscribe or clean up, all right? So you connect, but then you also disconnect, or you subscribe or unsubscribe. So now you have is this cleanup phase. So the way now how this works, especially on development, is because they're using this special tag as a way to now prevent some common gotchas. That is well, it'll come. But this special types strict mode. This is strict mode tag allows you is to prevent some common gotchas in React, which is, well, reruns your components. So it will re-render your components and it will re-render your components and it will recall your effect as a way to everything are as expected, or to everything were as expected. Again, this is a specific feature for that. And the idea here is that when you look at what use effects are, what offer, and what is the anatomy here, which is what will happen every time when you use an effect initially, okay, a setup function with setup code that connects to the system, okay. So it initially you need to pass two arguments to the use effect. One, setup function and a list of dependencies, okay. The setup functions, which is AKA this callback function. So you can look at this use effect that is, after all, is a high order function. This is just a fancy name to say this is a function that receives a set of instruction, another function, or it can return is another function. As a way to now is when you're giving up this set of instruction to this function, okay, anytime you want to reuse a set of information, or when you want to call that set of information, so for example, something that is useful when you are iterating through all of these elements, I want you to apply this particular feature for all of these different from all of these different features. I want you to apply this set of instruction, this set of rules to all of these elements, for example. Again, so use effect here is now the first you pass two arguments, the setup function and the array of dependencies. So React call your setup and cleanup function whenever it's necessary, which may happen multiple times. So your setup code runs when your component is added to the page, mounted, and after every re-rendering your component, and after every re-rendering of your component, when the dependency have changed, it will first run the cleanup code. with all props and state, which means that with all props and state you define here in this function, or under this set of function, and then it will run the set of function with the new state. Okay, and in development, it now will run your cleanup function again, which is on mounting. Your cleanup code runs one final time after your component is removed. So this is now the process of how this use effect actually works. It is use effects allowed to synchronize with external systems. So for example, with the animation or the window event listener, or to data fetching, as well as with analytics. So you want us to log to analytics and then keep track using the observer API to actually send that data. Okay, but this is made of the setup function and the list of dependency. So React will run this whenever it's necessary, and it may happen, which may happen multiple times. So what it does is to run the setup. So your setup code runs when your component is added to the page, when it is mounted, and after every re-render, your components, and after every re-render, when your components list of dependency change, first it will run the cleanup function with the previous state, and then run the setup function with this new state. And last but not least, your cleanup function runs one final time after the components is removed from the page, aka unmounted. Okay, that's interesting, and this is something important to understand as a way to describe this. Because, for example, without even actually to run this code, I would like you to describe as this. I would like you to describe as this. What this effect does. Okay? What this effect does, and use the React terminology to describe that. It will run the setup function. So when these components mount, it will run the setup function. Okay? And because this is on development, it will run now as the cleanup function, followed by the setup again. On production, it's only run the setup function again. So when you mount this component, that's exactly what it's doing. And after trying, you actually be able to do that. So this is pretty simple and pretty mechanical. This thing is not doing anything else. It's not thinking about it, so what will happen is no. It's doing this specific thing. And I think that's quite interesting. So each render has its own effect. Each render has its own effect. So you can think of the use effects as an attaching a piece of behavior to the render output. So like this. So you can think of use effect as attaching a piece of behavior to render output. Consider this effect. Let's see what exactly happened as the user navigates around the app. Initial render. So during the initial render, the user visits chat room general, and let's mentally substitute. Okay, and let's mentally substitute, which is a state as a snapshot, the room ID with general, which is welcome to general. The effect is also part of the rendering output. The first renders effects become is this. This is the setup function. With the general, because that dependency changed, and now it's going to be used that state in your setup function. This is what happened at the initial render. And when you re-render with the same component or with the same dependency, for example like this, React sees that the rendering output has not changed, so it doesn't update the DOM, but the effect from the second render look like this. It will run this again. With general, React compares general from the second render with general from the first render. Because all dependencies are the same, React ignore the effect from the second render. But it's actually comparing that. Because all dependencies are the same, React ignores the effect from the second render and it never gets called. Re-render with different dependencies. So when it render with different dependency, now React compare the travel from the third render with general from the second render, and once dependency is different, which is object.is travel and general is false, the effect can be skipped before React because it's using the object.is, and that to me is quite interesting. It's using the object.is. What in this case? Someone actually have that domain? Object.is. 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 Object.is is not equivalent to the double operator because because it performs some type coercion. It's not equivalent to the triple operator. The only difference between object.is and triple operator is the treatment of signed zeros and non-values. Signed zeros and non-value. That's one of the reasons it's preferred to use this. Okay. Both numbers are but treats none as non-equal to each other. It's because it's way much more consistent. Interesting. So from this moment on, I'm going to use this object.is to compare values. Yep. I'm gonna use the object.is. Hey, is this object, which is the building object, is this all the same value? Both are on the undefined null true string with the same length, with the same order. Both the same objects, meaning both values referring to the same objects in memory. Both begin symbols, both numbers. I get it. I French toast get it, bro. I French toast get it. This. Oh my god. Holy moly. Alright. Alright. Holy nigga. Holy moly. Alright. So this is travel in general. And that's what the reason why they use object.is. Okay. Say no more. Ain't gonna use it. Before React can apply the effect from the third render, it needs to clean up the last effect that did run. The second render effect was skipped, so React needs to clean up the first render effect. If you scroll up to the first render, you will see that it is a cleanup call. Disconnect. Once the but the thing is that because React is keep tracking of this and is compared with the previous value using the object.is, then React in this case say, hey, if this is different, now it is time to run the setup first. Now it is time to run the cleanup function, which is part of a re-rendering, with the old state, pretty much like a snapshot, and then the setup function with this new state. Holy moly. And the development only behaviors this. So that's quite interesting, my friend. Focus a field on mount. And that's what you have, for example, in Vue 2. These things like life cycles that allow you to have much more fine control about optimizations. Okay. User input. Use the user input focus method to make my input automatically focus when it appears on the screen. Okay. Okay. Well, in this case, because I'm gonna use to connect to an external system, which is making that happen. So on the initial render, I want you to run this. So use effect here. What you're gonna pass is the setup function, makes sense, followed by the array of dependencies, where in this case, I just only wanna run is after every render initially, or we can say after the value change, you know, the list of dependency. So what do you want to do? Because here we're holding is a reference, which is something that React doesn't keep track, and this reference holds is a unique value, so there is no need to actually pass the ref as it is. Okay, and we are receiving is this value from our input down to there. Okay, so what I'm gonna do is to say, hey, the reference of this current dot focus. Okay, so when you render this form, or when you render this, okay, so when you render this input, okay, and when that no, you can say, hey, on the initial rendering. So on the initial rendering, I want you to run this setup code for that. Like so. Mm-hmm. Exactly. On the initial render. The other is focus field conditional. Focus a field conditionally. So this phone renders to my input component. Press sure and notice that the second field automatically gets focused. This is because both of my input components try to focus the field inside. When you call focus the two input fields in a row, the last one always wins. Let's say you want to focus the first field. My first input component now receive a boolean should focus here. Props set to true. Change to the logic to the set focus is called here. If the should focus prop receive my input is true, well, now it will rerun this set of code after every commit phase when the should focus is different, meaning that it's going to compare the previous state with the new state using the op.is, and if they have different values, then it's going to run this setup function. Call focus only if should focus is true. Oh, okay. So if should focus is true, okay, then I want you to now run this. Mm-hmm. As a way to now detect that properties there. But your effect can include conditional logic because it's a setup function here. Mm-hmm. The other is a fixed interval that fired twice. Mm-hmm. Look at what's going on here. When you're defining is this, it's because you're saying is that when you set the interval here, when you're running this construct initially, it passing through the setup function, which means that at this moment you will have is at this moment. Interesting. So at this, look at what's going on. Is that hey, I'm going to run now this setup function, okay, where I go now is to work with the previous state, which is 0, okay, and 0 plus 1 is 1, okay, and I'm going to now set the interval here for that. It increments twice. Why is that? Find the cause of the bug. It's because the way how no use effects work. It's because on every re-rendering, okay, on every re-rendering, okay, on every re-rendering, it's because you are not work on every re-rendering here. What happened here is that on every re-rendering here with the count, okay, on every re-rendering here, what you're doing is that hey, I want you to now work with the previous state and doing something like this. I don't want to work with patches of this. So what it's going to do is this. Hey, is this change? It's going to initially it's going to run this setup function. Hey, it's actually triggered that, okay, which is 0 initially. That is going to be updated after 1 second. So then it's going to look at the count, and if the count change, it's going to render, it's going to trigger this code after every re-render, okay, which means after every commit phase. So after the screen updates here, it'll say, hey, let me now trigger this as a way to update the state. Right now it has 0 plus 1. All right, it will run that code, meaning that it will trigger is a re-rendering, where now it's going to pass through that, but this will be triggered after 1 millisecond. So what happened is that you are now is running this function after every re-rendering, okay, you're now running this function after every re-rendering, okay. So after every re-rendering, okay, is now saying, hey, I'm going now to set this function here, which is using is the previous state with the current state, which is, say, what is the previous state? 0. Then I want you to update that, meaning that this is running is this setup function is running twice, because it has setup, cleanup, setup, okay. And even though that this will actually run as it is, if I want to change that much, okay, it means that now you are working with the previous state. It's because you are now working with the previous state, but instead of using this, because now anytime this count change, which is an state, it actually will trigger a re-rendering, you can just do something like this. It's like, hey, I want you to now work with that previous state, all right, but because this is getting called twice, given the way of how now it's on development, on production it will work, it will only call twice. So what you can do is this. I want you to now is run this function on the setup once, okay, and then run the cleanup function here, set interval, okay, and then run the cleanup function here. That you must hold is a reference here of this, which is interval like this. And then on every, which is a function that you return here, your cleanup function. So after you run that, I want you to now clear the interval, and create a new one, which means that at the initial render, it's going to call this function. You're going to say setup, cleanup, setup, all right, which is setup, cleanup, and then setup, which is called as it is, you know, because otherwise what happening is that you are going is to call that function twice, you know, without a cleanup phase, because that's what happened. This is what now Yeah, this is what happens when you have this cleanup phase. When you don't implement the cleanup phase for that. So, for example, cleanup phase. The real cause is that the use effect start process but doesn't provide a way to clean up. Again, because on every time you're calling this piece of code is running the setup function, but the setup function and the setup function and the setup function, but without the cleanup phase. And this is fixed fetching inside an effect. This component shows a biography for the selected person. It loads the biography by calling an asynchronous function called fetchBioPerson on mount, and whenever person change, that asynchronous function return the promise. Exactly. Try eventually assign, which eventually resolves to a string. When fetching is done, it calls setBio to display that string under the select box. It's because you're setting the bio as null here. It's not cleaning up that. Exactly. If an effect needs clean, if you need to fetch something asynchronously, it also needs to clean up that, which is the cleanup function is this. Yet they ignore this. Okay. So that'll be all for this video. Take care. Bye bye.